Good evening and welcome to our first career conversation with Levi Strauss. I am excited this evening to welcome a panel of guests here with us to talk about some of the experiences that they have on the team at Levi and really how the work that they do on any given day really is applicable to the work that you've done or are doing on your first teams today. I'm Michelle Long, Director of Alumni Relations at First, and I am very excited to be able to welcome Renee Sarikanoff from Levi Strauss & Company. Renee?
Thank you. Good evening, everyone. Welcome to this session. And I'm Renee. I do product management for data and analytics at Levi's, and I'm going to try to get through this as quick as possible so that you can hear from the speakers themselves. We've got an awesome lineup here. But what you should walk away with today, you're already aware, every one of you, that we have very serious problems that we're all facing as a collective. You're interested in careers in technology. And what we want you to walk away with, and we're going to show you hard facts on how this is possible, is that you have a voice. Based on the careers that you're entering into, your companies are going to value your skills so much that you will have a voice and they will listen to you above and beyond what maybe they listen to from other folks. You can use your powers for good. So you're going to have technology skills that can be applied to solve some of these problems. And you're not alone. There's a whole lot of us out here who are rooting for you as you enter the workforce, as you start doing this good. We are with you, and we want you to know that you are supported. So what are we going to go over today? Well, first we want to talk a little bit about why on earth are you talking to Levi's? So if we can get to the next slide. We are the original Silicon Valley startup. So as far as technology goes, we kind of invented that business. So I'm kidding a little bit, but we are an original Silicon Valley startup. We'll talk about the history. The other piece of it is, and we'll jump into this right away, if you want to change the world, you need an idea and a pair of Levi's. Our company has a history of changing things and driving innovation, and we'll talk a little bit about where that started. So next slide. A little bit about the cultural impacts. So what we've put together here is a quick summary of just some of the folks who have been involved, and I'm going to date myself a lot because at the bottom are the people that I listened to growing up. I did listen to Willie Nelson, and yes, I did listen to NWA, and both of them claimed Levi's. So that's, sorry, my kid's in the background. We want to talk about a lot of the revolutions that have started the technology. Those 501s that you're seeing with the back pocket hole in them, those are the 501s that Steve Jobs pulled the iPhone out of when he introduced it to the world. So lots of culture, lots of innovation, change that we've had. And where it started, so if we go to the next slide, was a partnership. Jacob Davis contacted Levi Strauss. So Jacob Davis was a guy who sold goods and had a great idea. He reached out to Levi Strauss and said, hey, check this out, I got this idea. If we put these copper rivets into the fabric, it makes the jeans really strong. And he eloquently put it, the secret to them pants is in them their rivets. So copper into denim then, that's how it started. We got a patent for it. That's how Silicon Valley startups work. You come up with an idea, you partner with someone, you get a patent, and you start working. Fast forward, I'm going to turn it over to Paul Dillinger, who's going to talk about what it was like putting copper into denim then and how a Silicon tech company reached out to us about copper now. So I'm going to go quiet and let Paul talk a bit.
Thank you very much, Renee. It's a real opportunity to be able to share some of the work that I've been doing in the innovation space. I'm an uncomfortable panelist here because I don't think I like to think of myself as being agnostic around technology because I'm a fashion designer. I design the clothes, but the truth of the matter is the tools that we use to design the clothes and the clothes that we design are actually expressions of cutting edge technology, just like the rivet was an expression of cutting edge technology when it was first patented. It was a problem was identified, which is pants that were falling apart, and a solution was identified in the form of the addition of a copper washer and a copper burr, and making a point of strength where there was a point of weakness, and a patent on that. And that's kind of how it goes with the technology innovation that we work on these days. I'm the Vice President, Head of Global Design Innovation. And that's great. We can move forward to the next slide. But it's just a fancy title that says I'm a fashion designer. About October 2014. We get a call from our friends down in San Jose, and the friends at Google, in the Advanced Technologies and Projects Laboratory, with a proposition. They wanted us to come check out an opportunity for a new form of wearable technology. The technology, just shorthand, was capacitive yarns woven into fabric that could become flexible adaptive sensors that could become the conduit for a new form of tactile digital interface that would be different, that would be an evolution from the wearables that we knew. But we were really skeptical because we asked the question, will people wear a wearable? Because we hadn't seen a lot of pickup in that industry so far. If we go to the next slide, the answer is, of course, yes, people will wear a wearable. I mean, they've been wearing wearables ever since the first wristwatches were introduced, or even pocket watches. This idea that something useful could be put on a person's hand. But let's move forward again. Yeah, right pace on the slide moving. Yeah, the first thing that people did when they no longer had to get their time from a watch, when they could get it from their phone, is they stopped wearing a wearable. The first inclination was to ditch the wearable when possible, because they could get the service from something easier. So people started carrying a carryable. But then there was this. The truth of the matter is, it is a computing interface, and the impulse with all computing interfaces was to fetishize the complexity of the miniaturization. And as soon as we all got comfortable with our carryable, we started seeing more and more wearables that were these sort of smushed, scrunched interfaces, trying to cram as much of the digital activity into the smallest space possible, which seemed like a counterintuitive move on the part of wearables, to say that if our first response to having the time from something other than our wristwatch was to get rid of the wristwatch, why on earth would we think that reintroducing a new form of a wristwatch was going to be a solution, when people had already expressed rather clearly that their preference was to not have something around their wrist? So if we look at the next slide. One of the big problems with wearables is that they are generally limited in use and often inconsistent with the lifestyle of the person that we're asking to wear them. We see a person in a nice, bright, soft hoodie. We see a person with a nice sort of wooden acoustic guitar, and both of them are wearing this sort of like half of a space age handcuff. The materiality that's inconsistent with the lifestyle that's being expressed in these images is a clear indication that there's some disconnect between the design of the wearable and the consideration of the lifestyle that it's being designed for. If we move forward to the next picture, you'll see another expression of a sort of a single-use wearable, in this case, Spire. And I don't mean to be making fun. I'll make fun of my own product here in a second. I'm not making fun of any of these products. I'm just highlighting a tension between design and context. The idea that wearable technology is often an imposition, in this case, a literal add-on or a tag-on. And in this case, it's also doing something that you really expect your best friend to do. Hey, you're a little tense. Maybe you should take a deep breath. You don't really expect that as a service from a wearable, and certainly not the only service from a wearable. If we move forward to the next slide, I think it's a really good example of one of the challenges. Now, if you're going to have a large amethyst cocktail ring, and you're going to turn that into a wearable, and you're going to be dependent on the you sort of deeply integrate the value of that wearable into your lifestyle, what do you do on an evening where you have to wear a red cocktail dress? I mean, an amethyst cocktail ring looks terrible with a red dress. Do you ditch your wearable? Do you have to give up that piece of your digital life that you've invested in? Statement jewelry should be statement jewelry, and we shouldn't necessarily try to overinvest in doing something something else, because it fundamentally defies its original purpose. And so what we ended up with is this sort of lifestyle where a proliferation of wearables was really starting to kind of like dangle off of our lives. We ended up with the back of our sock drawer being richly populated with various wearable devices. Each one was a good idea, maybe, but none of them were necessarily considerate of the lifestyle that they were working for. They weren't considerate of the lifestyle that they were designed to integrate with. They weren't considerate of the materiality of that lifestyle. And eventually, most wearables get rejected and end up in the dreaded back of the sock drawer. And I can give some examples of our own work. The next slide, if you take a look at it, is a wearable jacket designed by Levi Strauss. It's a Levi's jacket from 2000, collaboration with most of Osti from ICD and then Philips Technology. And this is a breakthrough jacket that could hold 5 MP3s and could not be washed. And you can see it. It's kind of like this strange, awkward collection of varying pockets with pieces of evidently outdated technology. And the truth of it is, like, the technology was, the cycle of technology moves so much faster than our ability to produce new clothes and figure out new connectors and figure out how to make things encapsulated and washable, that the technology is changing more rapidly than our ability to integrate the technology. And so even a few years later, when the iPod came out, in the next image we'll see Project Redwire from Levi's, which is 2007. It was an attempt to integrate the interface of the original iPod into a pair of jeans, and to transfer the control of the iPod to the coin pocket. You see the white circle there had the forward, back, pause, play, and then the long red cord that was the correct plug for the original iPod. But within a year or two, that plug had changed. But the jean is supposed to be a garment that lasts 5 years, 10 years, 50 years. We've got jeans in our archives that are over 100 years old and are still wearable. And then also that the coin pocket with that white control there, that was velcroed on because that piece of the control could not be laundered. There's a fundamental tension between the idea of wearable technology and its expression. And so what the net of all of this kvetching about wearable technology is, if we look at the next slide, there's a simple lesson. When it comes to wearables, technology is really hard. And it's the truth that we have to accept, that none of the work that we're doing is easy. And so when you're confronted with work that's kind of difficult and is kind of maybe providing a dubious value to the consumer's life, you really have to be skeptical about approaching it. You have to be cautious about it. And it's oftentimes we just presume that digital value and technology innovation is a fundamental benefit, and it's not necessarily the case, but it can be if we move forward. It can be if you have a really good reason to do it. Now, the challenge for us, if we move forward again, is to think about what the Levi's brand is and what the texture and the materiality of the Levi's brand is. As a designer, that's what's most important to me. It is blue, and it is textured, and it is washed, and it is rumpled, and it is casual, and none of these things are necessarily a good fit for the imposition or integration of wearable technology. But we did have back when we first started this conversation with Google about integrating wearable technology into our product, we did have a sector of our assortment called Levi's Commuter, and you can start to see it over the next few slides. You'll see it's about smart design for urban cyclists, modifications to classic Levi's product that make them better for the commuter, better for the person riding their bike around the city. The little flaps there that are actually retro-reflective, so that your jacket can be converted into a protective gear for when you're on your ride. If we look at the next slide after this, we'll see it's basic blue denim, but it's been treated with certain chemistries that allow it to be resilient and water resistant. It's got a place to put your bike lock. It's got retro-reflective on the interior cuff. It had all these smart little design modifications that made it gear for the ride while still maintaining its presence as a pair of jeans. Now, here we see is there's a certain challenge that all the people who are riding who are part of our commuter community, who are riding bikes around the city, smart design for urban cyclists. Now, these smart urban cyclists are still looking at their phones. We would see this all the time when we would see cyclists in the city that were either scrolling through their music or they were checking out their text. And they'd always cut me off while I was driving around, and I'd curse and I'd shake my fist at them. And I would realize what enabled me to curse and shake my fist is that the key features that I needed to control the digital apparatus in my vehicle had all been transferred to the steering wheel. That on the steering wheel of my car were the key features, like answer a phone call, hang up a phone call, track forward, track back, control of the volume. The complexity of my dashboard in the car had been collected, and the most essential features had been presented to me for access on my steering wheel. And that premise, the idea that we could collect the most essential features of the digital engagement that the consumers were risking their lives by fiddling around with on their bikes, and we could transfer the control of those features. As we go to the next slide, we could transfer the control of those features to the cuff of the jean jacket. So what you're seeing here is a jean jacket with 15 capacitive yarns, initially developed as copper yarns or copper wires that have been braided up. We added a few other metals in there to make them more resilient, but these capacitive yarns were woven into the denim as little parallel lines across the cuff, so that when gesture across the cuff occurred, tapping or holding or swiping, that gesture could be read by the garment and then translated by a little microprocessor within the garment into a signal, that it would recognize the gesture, turn it into signal, and then you would snap on this little strap on the interior cuff, and that strap had a Bluetooth mechanism that could take that signal and send the signal to the phone, and the phone would understand the signal and as having meaning. And now you could reconfigure this meaning all different ways. We gave a suite of different capabilities now around navigation, around control of media. And if we skip forward to the next slide, we'll see this is the final form of JACCARD version 1. It was smart designed for the urban cyclist. And if we skip again one more, what we can see is what we were able to do is take all of this digital value and put it into a garment with a pretty accessible price point. I mean, it's not cheap. It was $350, but it had all of these really interesting performance features, like it could you could control your media, you could answer a phone call, you could silence a phone call, it could understand when you were in bike mode and filter out the kind of notifications you were getting. What was most interesting about this, and I want to kind of focus on this part, is the usage data. For the first time, we actually knew what was happening to a garment after it was sold. For the first time, no, can we go back one? For the first time, we were able to really dive into how the consumer was engaging with product. We had designed it for the daily commute to and from the office, but no other product we'd ever designed would we actually know was being used that way. And I put in here some of the initial usage data from the first few months of our JACCARD launch. What we were finding is that people were wearing the jacket about 4 times a week, which roughly corresponded to a work week. And it's a lot more than, I mean, I think it's pretty good. If you're a designer and you have to put something out there that someone's wearing 4 times a week, it's kind of a win. They were wearing about 4 times a week, 2 sessions a day that were of 20 minutes or more in length. So that roughly corresponds to the average daily commute. So 14 gestures per 20-minute session. Now that's really rich engagement. You're not just using it once or using it as a novelty, but 14 gestures means that twice a day, 4 days a week, they were really engaging with this digital innovation. And the favorite function was, as we anticipated, was the media player. The ability to track forward, track back, to actually be able to double tap and remember the song you were listening to. If you were on like a Spotify playlist, it could record that and send you a text with that hyperlink so that you could keep track of the song, so you didn't have to like pause and check out what you were listening to if you wanted to remember. They were just really simple things, but they made for a safer ride. It allowed people to be more present, more aware, more focused on the beautiful world around them, and also some of the hazards of the road around them, and not be so worried about their digital life. And then there was a rollout of additional features. When we saw that the usage was sort of plateauing during the week and dropping off during the weekend, we introduced features that made this the perfect weekend jacket. So after about 6 months in the market, we introduced interface with, we opened up the APIs and allowed for interface with Lyft and Uber, so that you could call your car and your jacket would let you know when your car was coming. And then a few months after, a little bit later that year, actually about 6 months later that year, we introduced the always together function, which means if you left your phone in a bar and you walked out, your jacket would freak out. The cuff would start buzzing. You would go back to the restaurant and pick up your phone. Vice versa, if you left with your phone and forgot your jacket, your jacket would panic and send a text message to your phone. So we were able to update that and provide additional service as time went by. So we were able to show that JACCARD could be useful. We'll go to the next slide. And then it could be useful. We could integrate this technology in a way that it wasn't just a gadget. It wasn't just a single-use add-on. It wasn't a clip-on. It wasn't a half of a handcuff. It wasn't a weird ring. It was something integrated and useful. Because even if you weren't using the digital function, you still had a great jacket. But if we move forward again. We found that useful wasn't essential, and that the usage would taper off, and that we weren't really kind of like breaking through to the broader Levi's consumer. We were still dealing with a niche consumer. So we wanted to understand what makes something essential. What are the real problems that we're trying to solve? You need to have the right reason to integrate technology, and that was really the sort of the focus of the next phase of our evolution. If we can move forward to that. the real problem with all of this is not that consumers need digital awareness when they're on their bike. That's sort of a niche, kind of a novelty issue we're trying to solve. The real problems of the fashion industry is that the fashion industry is a frivolous industry. We frame it in terms of fashion cycles. We think about it in terms of silly designers like from Zoolander, or silly editors like my friend Anna De La Rosa here, who I went to school with. I'm allowed to make fun of her for this. We think of it as sort of like this silly, elaborate, non-functional, highly decorative industry, when in fact it's actually a very large and very dangerous industry. One of the largest drivers of ocean plastics is the fashion industry. And you don't really think about it because it's not a plastic bag or a straw. But every time you wash a polar fleece or anything with polyester fiber, you're shedding tremendous amounts of microfiber pollution into the local waterways and eventually makes it into the ocean. But because you can't see it, we don't think about it. But if we move to the next slide again, the fashion industry is in fact a dangerous industry. There's a flood of product, far more than is necessary. There has been an 8-fold increase over the last 30 years in actual quantity of garments produced, but that quantity of household discretionary income over the last 50 years has gone from about 12 or 13% down to 2%. So incredible drop in price with an incredible increase in production. So we're making much more product with much less value, and that flood of product is creating a drought, a loss of resources. We're depleting our natural environment of essential resources. We're polluting the environment. The apparel industry may represent about 10% of the world's carbon emissions and may represent about 20% of the world's water pollution. Those are the real problems that we have to solve for. If we move forward again, the problem can be is that the garments that we make have more impact than we're aware. This is from old LCL life cycle assessment data from the company, and Byron can give us new numbers, but about 3,781 liters of fresh water per unit consumed in the life of a garment. That's enough drinking water for five people for a year. That's a tremendous amount of resource investment. If you move to the next slide, what we see is, unfortunately, we're investing a tremendous amount of resources in large closets, but about 6 out of 10 garments that are produced every year are discarded or landfilled or incinerated within the first year of production. So the truth is, like, 6 of the 10 things we're making are getting pitched. And what is the impact? The average consumer, no, that's good. The average consumer is buying 59 garments a year. 60% discard rate is 35 garments a year. The water impact of that many pairs of jeans at 3,781 liters of fresh water is enough drinking water for one person for 181 years. Annual consumption creating waste of that magnitude. That is the real problem we have to solve. And so the question is, how can technology be the enabler for that solution? How can wearable technology change that? And the way that we can approach that is by design for essential. What makes the 4 things stay in the closet while the 6 other things get thrown away? What are the qualities or attributes that we as designers can strive for to embed in a garment to make it that essential thing that doesn't get thrown away? And how can wearable technology be an enabler for that essentialism? Whereas so much about the wearable technology that we saw earlier was much more about the trend or ephemeral or the moment or the hype or the getting attention and not necessarily creating value. So that's the question that we put to ourselves for the second version of JACCARD, integrated technology, was, if we look at the next slide, is what is essential design? And we hope we've answered it. And so I'll conclude with a video that describes how we molded and shaped the design proposition of Project JACCARD, the Google integrated wearable technology, into what we hope is an essential form of wearable technology design, with the aspiration that it be something that stays in the closet for a much longer period, and it's something that can be adapted and updated, something that can be improved over time, that doesn't become obsolete or time out too quickly. And so with that, I'll like to take a look at a video describing version 2 of JACCARD.
The weather downtown is currently at 65 degrees. Today at 10 a.m. you have a dance audition. Traffic is heavier than usual. It will take you 23 minutes to arrive at your destination. Turn west on Broadway Avenue.
But hey, I'm about to jump in the elevator. I'm moving.
All right. Thank you, Paul. That was very cool. All right, so we just heard a little bit about how technology getting incorporated into design. Paul talked about a lot of really important things. One of the real big issues that we face is water. He talked about that. So now we're going to switch gears a little bit and look at how focusing on one specific problem, like water, what we're doing, and what better place to start when you talk about water than our washing machine. So among other things, Byron's going to talk to us a little bit about the washing machines. I'm going to turn it over to him. So Byron, it's over to you, man.
Excellent. All right. Well, thank you very much. Great to be here. So my name is Byron. I'm on the sustainability team, and among a variety of different things, I oversee our water program here at Levi's. And I often get kind of asked the question by friends or strangers. They say like, "Wait, what does water have to do with jeans exactly?" And it's obviously a good question. Like when you think of companies and water, you probably think of like a beverage company or something, or maybe a shampoo company, but you probably don't think of garments. And so I want to talk about that a little bit. Paul actually made the point better than I could in some ways about why water and jeans have anything in common. And it's actually much more of a connection than you probably realize. So what I'm going to do is kind of talk through what do we do about this issue from kind of a manufacturing standpoint. And this will be kind of a useful bridge between the kind of visionary capabilities from the design realm that Paul just showed, and then the next speaker, Bart, is going to really show you some of the kind of artisan and technical abilities that go into making jeans and how you can use technology to do that. So you can go to the next slide. We can actually probably skip through. If you're paying attention to Paul's presentation, you probably already know the answer to this. But here's a pop quiz, I guess you could say. The answer is 3,800 liters of water to make one single pair of jeans. That's about 1,000 gallons of water, if for those who don't like the metric system. That is a staggering amount of water. And like Paul said, if you multiply that by the number of jeans that the average person wears and then discards, you get 181 years worth of water for one single person. And Levi's is a small company in the grand scheme of things. I know we have a very big brand, but in terms of revenue, we're only about 1/5 of the size of Nike or Gap. And so you kind of understand the magnitude of the situation that we're talking about with water and the apparel industry. You can go to the next slide. So our flagship program to deal with water in manufacturing is a program called Waterless. It is essentially a collection of technologies and techniques to reduce water usage when making the garment. So we still get the same aesthetics in the garment that we all know and love and expect from a pair of Levi's, but it uses less water to do it in the first place. This is a program that's been around for about 10 years or so. To date, it's saved about 13 billion liters of water since its inception. And keeps going up and up and up. And so you can go to the next slide. I want to give you just a visual of what a factory looks like for apparel. This is actually a fabric mill here, just so you can kind of understand and kind of see like the size of a factory. It's hot, it's steamy in there. You can actually, if you see the top of the screen there, you can see that is raw denim fabric. It actually is lowered down into these big baths, these vats of indigo dye. And that's how you actually dye and kind of stain the fabric with indigo dye to turn it into denim. And a fun fact actually is that when they take the raw fabric and dip it into the indigo, it actually starts as green. And it's only when it's exposed to air that it oxidizes and turns to the blue that we all know from indigo. So let's go to the next slide. The cool thing about what we do in sustainability is that it's always a mixture of technology and technique. And so there's a place for engineers and there's a place for thinkers and visionaries and clever people to do what we do and save water. So here's a very simple example. This is a picture of stonewashing. You may have heard that term before. Stonewashing is exactly what it sounds like. It is washing with stones. And so you may have sometimes wondered, like if you get a pair of jeans, sometimes how did it get to be like it looks like it was pre-worn by somebody else, even though it's brand new? It may have looked like it's been worn away. Maybe it's even been cut and distressed. Maybe it feels like it's broken in, but it's brand new. Like how do you do that? Stonewashing is one of the main ways you do that. This kind of equation on the bottom is so simplified that Bart is probably rolling his eyes, but let me boil it down. The way they do it is they take these industrial sized washing machines, which is what you see in the picture. It is like your washing machine that you have at home on steroids. The sucker is huge. And they put the jeans in there, they fill it with pumice stones, which is a very porous, soft rock, add a bunch of water, sometimes add some chemicals like fabric softeners, optical brighteners, detergents, etc. And they roll it around, and that pumice stone and the chemicals and the water kind of it rubs away some of the top layer of the jeans and gives it that worn, soft look that we all know and love. But when you get down to it, it's kind of a primitive process. This technology has not changed a whole lot since it was invented. So we thought about, well, can we get that same effect, that same look, that same worn, soft look in a more clever way, maybe using some technology and hopefully use less water and create less waste in the process. You can go to the next slide. And so one thing that some suppliers do is instead of using a step in the process where they add a liquid fabric softener. So you imagine like one of those big baths like you saw in the picture, they'll take the garment and they'll put it into this big vat of water that has a liquid fabric softener in there, so it kind of softens the fabric. It's possible to get around that step and still get the same effect by actually putting, you can put golf balls, you can put bottle caps, ceramics, rubber balls, anything that's hard essentially, along with the jeans in those big industrial washing machines, roll it around a little bit, and it will soften the fabric. And you've done that without using the chemical, which is the fabric softener, and using a whole lot less water in the process. Very clever. And you can see this is not like a super engineering approach, it's just very creative. At the same time, the pumice stone itself is also a problem. This is a very kind of old-fashioned way of doing things, and it is lovely in certain settings, but at scale that Paul was talking about, it is very destructive to the environment. The reason is such: that pumice stone has to come from somewhere. Pumice stone has to be mined, comes out of the ground. If you know anything about mining, it creates a ton of water pollution. It's very environmentally destructive. So somebody has to dig that pumice stone out of the ground. They put it on big ships. Those ships travel around the world. That releases pollution like anything else, carbon emissions, soot. And then once factories get a hold of that pumice stone, it takes about 278 grams of pumice stone to stone wash a single garment. That's about 40% of the weight of the final garment, by the way. And then after the jeans and those rocks get tumbled around in the washing machine enough times, the pumice stone slowly degrades and turns into sand effectively. And then that sand is flushed away down the drain. It ends up in lakes, rivers, the ocean, into other aquatic ecosystems. It's a very linear process. It requires a whole lot of pumice. And so one way around that is that we're seeing some suppliers using synthetic pumice stones. They're actually, oh, no, go back, they're using the synthetic pumice stones that can be reused 3,000 times as opposed to regular pumice stones, which can only be used 3 times. You think about, and you can reuse those stones over and over again, and that means you don't need to dig up as many pumice stones to begin with from that mine. Go to the next slide. Here's another example of what we sometimes do. Sometimes garments need bleaching or dyeing in very small amounts, kind of in very specific parts of the garment. And one way you can do that, if you want to get a part of it or the entire garment, is you can kind of dip the whole thing in a big bath, or you can apply the whole thing with a lot of bleaching or dyeing. One way around that is you can use a very surgical approach, and you can use a foam that has concentrated bleach or a dye or a tint solution, and you can apply it manually into the specific parts you want. Again, it's technique rather than technology, but sometimes that's all you need. If you go to the next slide, though, you see kind of the technology over the technique. And this is a picture, I believe it's actually from Bart's lab. He'll talk to you in a minute. This is an ozone machine. If you add ozone to a washing machine, you don't even need water to begin with. There's no water necessary. That ozone will act like bleach, and it will lighten the fabric, and without any water at all. It's pretty miraculous. The caveat on that, though, is that ozone, when inhaled, is actually dangerous, believe it or not, to workers, to any human being. And so you need to be very careful and have dedicated machinery and safety training for those workers. Yeah, so that's all I wanted to show you there. So there's lots of different ways you can do it, but I think I always find it heartening to know that if you're not an engineer and you're not a designer necessarily, we still need people like you to think through, what's the most clever way to use the techniques and technologies that we have.
Byron, that was awesome. Thank you very much.
Sure.
All right, everyone, we've seen a little bit about how we can incorporate technology into our design, how it needs to be essential. We talked a little bit about how we use techniques and technology in solving some of the biggest problems. What we're going to talk about next is kind of interesting. All of that starts to come together in this one effort that we undertook to solve a problem that ended up haloing into something amazing and ultimately is an incredibly strong competitive advantage for the company. So this kind of brings it all of that into one place, and who better to tell you about it than Bart's site. So, sir, I turn it over to you so that you can walk them through the really cool things that have happened.
Thanks, Renee. Hello, everyone. It's nice to talk to you. My name is Bart Seitz. I'm head of technical innovation at Levi Strauss & Co. I also lead the efforts at our Eureka Innovation Center here in San Francisco. Before I get into the things that Renee referred to, I'll give you a quick background on me, which will lead into what we do at Eureka. Because I think I'm probably a good example of the fact that at the very young age of 17, 18, 20 years old, it's really impossible to predict the path that life and your work is going to take you down. At least that's the case with me. I'm from a small town in Western Kentucky. I went to a small liberal arts school, Center College in Kentucky. I went to college and I wanted to be a pediatrician. I had a father-like figure who was a pediatrician in my childhood, who was kind of a hero to me, and there was no doubt that's what I wanted to do with my life. I got to college. I failed chemistry my freshman year and ended up majoring in econ and English, and left my 4-year college actually having no idea what I wanted to do after college. That summer afterwards, ironically, a member of my family heard about this crazy notion that people were starting to wash blue jeans in an industrial setting. My father was at a sort of a crossroads in his life, a change in directions, and on a whim, with one washing machine, like Byron showed in one of those photos, and a load of pumice stone, which he also talked about. This was like 1986. We started a company to wash jeans. And I've literally been doing that ever since. So it's my whole career. We worked for 20 years, built that into a really nice company that ended up being one of the best known in the world for what we do. We closed it in 2008. I moved to India for 2 years from Kentucky and worked for a denim mill. And then Levi's called me, and I moved to Turkey and built a product development center inside a factory there. And then in 2013, we moved that product development center here to San Francisco, and that's now what we call Eureka. So I think the thing I want to point out in that first part is you really need to embrace those parts of your path that don't necessarily make sense at the time, that don't compute, because you never know where it's going to take you. Okay, now more about Eureka. You want to show the picture of Eureka? There we go. Okay, so this is our home. This is our workplace. We like to say we work at the intersection of art and science. We research at a component level. We're a small factory. We can rapidly prototype pretty much anything you see at levi.com or in our stores. We can make one in here to test it out. And we mostly work on projects. We worked on, we did a lot of work closely with Paul on Project JACCARD, which he had such a great presentation about. We basically worked out the componentry and tested it to make sure that it was viable. Another project that we worked on called Screen Chemistry was quite unorthodox at the time. This goes back a few years, maybe 2014, 15. The traditional approach to chemical management detection. So we took sort of the opposite approach with Screen Chemistry and said, okay, we're going to come at it from the hazard side. It's going to be hazard-based versus risk-based. The advantage to hazard-based is you try not to let anything hazardous get into the beginning of the pipe. So if you can screen those things out in the beginning, then you don't have to worry about mitigating all that risk on the back end. It sounds very simple. It was very difficult. We ran up against big chemical companies around the world who did not necessarily want us to take that approach, because we would be taking a hard look at their chemistries and the components in their formulas. One of the things, eventually we were effective, and we got the system installed, and the industry has over the past few years embraced it, and it's moved forward. One of the things that we found when we were starting to screen all the chemicals that we use was there was one that we needed to phase out, and it's something that we use a lot of. It's an oxidizer called potassium permanganate, similar to the oxidizer that Byron talked about, ozone. It's useful for us to remove color in parts of the jean. Most finishing in jeans, and when we talk about finish, that's the color, the shade, the localized abrasion, the holes, the hem treatments, patch and repair, all that stuff. So one of the things that we needed to phase out because of our screen chemistry initiative was potassium permanganate, which was an oxidizer that's potentially harmful. When we were looking for alternatives to potassium permanganate, we struck on the idea that we could use lasers to execute the same, answer the same need. So a laser, many of you know lasers from eye surgery or other methods that they're used for, but the denim industry has used lasers for a while, and we actually are able to mark the surface of the jean in a controlled way, in a pattern. So we lift the wear pattern from an inspiration jean, usually self-worn or vintage or from our archives, and we're able to use that as a manufacturing input. So lasers led us to an approach that we call FLX. You want to show the next slide? So FLX is a radical transformation in denim finishing. Denim finishing, Byron talked some about it. It's traditionally, it's been a process that's very inventory laden, it's very labor intensive, and the effluent is very heavy. It's not a pretty process. The FLX process endeavors to bring solutions to those challenges, like inventory, manual labor, and effluent, by using lasers to achieve the complete finished aesthetic. So that's a good example, I think, of how we sometimes, we're on a path to something, and a light bulb goes off and takes us on maybe a different trajectory that opens up something even bigger. So in summary, again, like repeating what I said before, I urge you to embrace those parts of your path that don't seem to make sense at the time, because there's usually a silver lining. And the other thing I would urge you to think about is, don't necessarily accept a situation where you don't feel challenged. Every single one of you, your voices, your opinions, your know-how is valid, and it shouldn't go to waste. Even in a company like Levi Strauss, which you wouldn't think about normally, that talent and know-how is very critical to our future and the future of the world. All right, Renee, I'll hand it back over to you.
Awesome. Thank you so much. That was very cool. Hopefully you guys were as inspired about seeing some of this cool stuff as I've been working here. So this is your call. You've seen a few things about how we've taken technology, incorporated into really like everyday things. So there's nothing more common or mundane in this world than a pair of jeans, and you see how going into a pair of jeans, how many technological innovations go into it, and how much good can be done for the world, and how it can help all of us. So you're heading into the fields of technology, you have a voice, use it, do good, and always make sure that you're inviting more voices to the table than fewer. So we want to make a very inclusive, very diverse technological world. That's how we're going to solve our problems better. I think we're going to pause a little bit for questions here. So Michelle, I don't know if we have questions, if we're going to take some, if we've got some already.
Yeah, I think if there's anyone who have questions in GoToMeeting, you can use the questions panel and submit any questions you have for any of our panelists or Renee who shared with us this evening. In the meantime, if anyone else is willing to share, I would love to hear more about folks' backgrounds, similar to what Bart shared, and how the unique path that he got to where he is today. So, Renee or others, would you be willing to share your own path?
Yeah, since I'm on the camera, I'll go ahead and kick it off. I started out studying, well, I started out going into engineering and didn't do real well. I got a 1.3 my first semester and was on what I call Alpha Pi. You may know it as academic probation. They almost threw me out of school. So I switched gears and went into finance. And when I was leaving school with my finance degree, I thought, yes, I will go into finance. And there was one job listed at Gap, and it was for inventory. And I was like, well, units are for peasants. I'm finance, I do dollars, but whatever. It's in San Francisco, close to home. I'll take that job. And I fell in love with moving inventory from point A to point B, and started working on, I taught myself a little bit of coding. I started working on little small tools that would make my life easier, and started working with IT departments to build those tools. And that just slowly started moving me more and more closer to the technology until 2 years ago, officially, I moved into the IT department doing data and analytics. So I took a kind of a roundabout way to get into technology as well. So I'll turn it over to Katie now. Looks like she's online ready to talk about her path.
Yeah, hey, just wanted you guys to see there's women in technology too. So I've been at Levi's for about 20 years, and I do have a background in engineering, industrial engineering, and have done a blend of business and IT and process over my years here at Levi's in many departments, including planning and analytics and a little bit of retail along the way. So all of the collection of the time I've spent at Levi's has kind of informed my current job, which is over IT planning systems in our supply chain. So, as our speakers have told you, your collective experience is kind of, you bring with you along the way, and you learn from them, and they inform kind of your path forward a lot of times. But I would also like you to know that just because I have this current path, there's also in my background, I've lived overseas. I was a Peace Corps in West Africa, and I taught and have done some other things in my background as well. So, we're not just the thing that we're showing up as on our screens to you today. I think there's, bring your whole self to your work and follow the things that interest you. And, if you're not pure IT, that's okay. We have all sorts of backgrounds here, and all those interests play out in different ways. Anybody else want to chime in? Thanks, Renee.
Thank
That's
you.
great. Thank you, Katie and Renee. And I see that Paul has popped up, and we did get a question that I think will be for you anyway. So why don't you answer, and we can ask the secondary after. Oh, I'm not hearing you. I'm not sure if other folks are. Oh, it looks like you're muted. Try now.
There we go. Yes, thank you for unmuting. Just a quick on my background. I went to art school, so I'm sort of dabbling in the tech space, but really enjoying it. I went to art school and got my undergraduate degree at Washington University in St. Louis as a fashion designer, and then went on as a Fulbright scholar to Italy and lived there for 2 years, and completed my graduate degree at the Domus Academy, which is also, where I got a MFA in fashion design. Then I went and started the traditional fashion career in New York. I was at Calvin Klein for about 8 years. I worked at DKNY. I started a new brand with American Eagle. Got disillusioned and sort of fell out of the fashion industry and became a professor was a professor of art at WashU in St. Louis at my alma mater. And I was focused on sustainable design systems at WashU. And then while I was there, I got a call from Levi's asking me to come out and said, hey, come do come do cool shit. That was really the proposal, and that was about 11 years ago. I'm still back and forth between academia and the design studio right now, teaching a course at Clark Atlanta University, which is an HBCU with a fashion program in Atlanta, and it's a program that developed through Levi. So I get to, again, bring the whole self to the job. But anytime I've had a job, I've always been a tinkerer, and anytime I've been brought into a company in a design role, I've ended up in some sort of weird experimental developmental role, because I like to tinker with things, and hands-on innovation and invention and really staying connected to making things has been one of the through lines for my career.
That's awesome. Thank you so much for sharing, Paul. And there's a couple of questions that have come in that might be for certain individuals, or each of our panelists might want to pop in, so feel free to answer or not as you would like. But the first question is if anyone would like to elaborate or share more on any other environmental impacts on the processes in making jeans that you've seen or experienced or are working to try to alleviate.
It's me or Byron. Who wants to take this?
Go for it, Paul. You can do it better than I can.
Okay, Byron spoke about a lot impact mitigation through modification of process. Another really important way that we approach impact mitigation is through new materials. We know that cotton is our core material, but it's a renewable resource, but it's an incredibly thirsty resource. There's a considerable amount of pesticide, herbicide, fertilizer, sort of petrochemical derived chemistries get invested. They become effluent. They become unhealthy. They create unhealthy conditions in our waterways and in our soil. And so a lot of our work has been around either healthier grown materials, materials like cottonized hemp, which is an innovation that Levi's launched in spring of 2019, which is a way of modifying the decortication process of hemp to make it something that's much more cotton-like, that can move through the cotton supply chain. The advantages of hemp is that we're using rain-fed hemp, so all of that water impact, the 3,800 liters that Byron describes, 2,565 of that is actually invested in the field, and so hemp eliminates all of that from the field. Hemp also has highly favorable carbon footprint and highly favorable land use footprint. Other solutions are ways of recycling, better ways of incorporating recycled materials into our product. We've been working with a Swedish company called Renewacell on a method that uses green chemistry to chemically recover and reduce old jeans into pulp cellulose that is then re-extruded as a new post-consumer man-made cellulosic fiber that with very similar material properties to cotton. And then we've been able to integrate that at levels as high as 40%. So 40% recovered material into garments. We make the balance of the garment with organic cotton, and then we make all the material components of these garments out of cotton as well, and create garments that are 100% cellulosic materials without any sort of pollutants. And that's how you both integrate recycled materials and then also create garments that are fundamentally recyclable. So we know that there's considerable impact in the material creation space, but the recalibration of materials in order to mitigate impact is a whole area of science that's really exciting and a lot of new opportunity. And if any of you are so inclined, I encourage you to get into it. It's a hot topic right now.
Fantastic, thank you. And then the last question that came through, which again, kind of dependent on who would like to answer it, is one of our attendees is wondering why the process is to remove color from denim after it's been added versus not adding that color in the first place.
Okay, Bart's
Bart's trying to talk.
Okay, so the yarns that are dyed blue it's something called a rope dye process. The rope dye process doesn't fully penetrate the yarn to its core. When those yarns are then woven, they're only woven in the warp, the length of the garment. So you have long blue lines, right? And the core of each of these lines is white. Oh, when you wear a jean authentically over time, only the surface of that yarn is knocked off. The color is knocked off, exposing that white core. But just on the exposed surface, the rest of it stays blue. And so you get these sort of faint, or these deviations from the original blue to the light of the core, and those create a certain wear pattern. The wear pattern is caused by surface abrasion over time, and the wear pattern is sort of like assessed against its relative authenticity. Does it look like a real wear pattern? There is no way of actually creating the garment from scratch with that authentic wear pattern. The wear pattern is unique to its location. The wear pattern is unique to the relative age of the garment that it's mimicking, and all of those different variables are impossible to account for in any state other than the finished garment state. So it has to get made. It has to get made first, and then have the color removed, because removing the color in the right spot, removing it in the right intensity, removing it in the right cast. And it isn't a process that could be done in the garment dye, vat dye, fiber dye, yarn dye space. It has to be done on a completed garment. I hope that's a fair summary. Unless if Bart's off mute, then he could probably weigh in on it. But
No, that's good. Yeah, that's a good explanation. I mean, the interesting, it's a great question, because the interesting thing is, you think about wear and wear patterns, and they're so part of our everyday vocabulary. And it's only in the past 30 years has that been, a part of what a jean looks like that's sold. Originally jeans, when Mr. Strauss first started wearing jeans or making jeans, miners wore them, and they wore them rigid, not washed. They bought them with the rivets and worked in them, and then Levi's was associated with workwear, and then became much more of a fashion statement, with Marlon Brando and James Dean. And when you look at those jeans, and we romanticize about those jeans, they were worn. They were worn by cowboys, and in the way that Paul described. And only in the past 20 or 30 years has the consumer started to want jeans that are made to look like that. And that's really created all this stuff in finishing that we don't like, and that we're trying to mitigate, with technology, because it's a big, complex, time-consuming part of our process.
And we started off by saying, how do we design it to look right? We did not start off saying, how do we design it sustainably to look right? Right. So now we created this. The diversity of our assortment is dependent on these finishing levels, and so that's essential for our business. If we'd only been thinking about the product creation process then, like we're thinking about it now, we wouldn't be in this position of having to correct so many problems. But so it's
yeah. Absolutely. And I think that's why, if this is at all helpful to the group, that's probably why I'm so passionate about these technologies now, because when I started in the 80s, with my dad, with one washing machine, we had no idea of the harm we were doing. We weren't, we weren't knowledgeable. It was an industry, literally in its infancy, and we just, it was like the Wild West, and we developed processes that the industry became dependent upon, and I'm not proud of that, and that's why I'm so hell bent on doing some of these things to change it.
Well, I think that's an incredibly powerful way to end this conversation. Renee, I think you've got one last slide if you want to close us out.
Sure. One last thing before you head out. We've talked a lot. You heard a lot about rebels and changing the world. Just know that even in galaxies far, far away, those are actually Levi's that he is wearing. So even in Star Wars, even in galaxies far, far away, rebels wear Levi's. So we wish you all a good evening. We wish you all the best as you head out into your technology careers. And we are eagerly awaiting all of the good that you will do and how you will change the world. We're excited. So thank you for joining us.